Chapter 5, Lesson 1. In this chapter, we'll talk about the periodic table, the most important document in the chemist's tool belt. We'll talk about its arrangement, the properties of the different elements, and everything that pertains to it. So let's first define what we mean by the term periodic. Why is the table called periodic? Well, the word periodic just means every once in a while, meaning regularly. So if you take a look at the elements, if you string them out, all the elements, just in one line, you'll see that regularly you'll find similar properties come out. And that's what we mean by periodic. Elements have similar properties at regular intervals. Here's a graph. We're not going to go into explaining what this graph looks like or why it's arranged the way it is, but just realize that if you take a look at it, at the peaks here, every time you see a similar property. So every once in a while you see a similar property, and that's what we call this a periodic table. Now the arrangement of the table is usually credited to a fine gentleman by the name of Dmitri Mendeleev. He is of Russian origin, a very wonderful country, and he is the first to arrange the elements by atomic mass. Now today the elements are not arranged by atomic mass, they're arranged by atomic number, meaning the number of protons. Today they're arranged by the proton number, but the first attempt was made by him, and his periodic table looks remarkably similar to today's. Not only did he arrange it in the right way, he also discovered what's called the periodic law, the idea of regular intervals, the similar properties show up, and he also predicted undiscovered elements. If you want your name to show up in a science somewhere, what you have to do is your theory that you come up with has to predict new discoveries, and that's exactly what Dmitri did. His periodic law predicted the discovery of new elements for which he is given credit. Not only were they discovered, but their properties were also discovered. And that's why Mr. Mendeleev is given his own element. Element number 101, Mendeleevium. So let's talk about the breakdown of the periodic table, how we arrange it, what we call things. First of all, groups on the periodic table are what we mean by the vertical columns. So we call these groups. For example, here is group 2 on the periodic table. Here is group 14 on the periodic table. These are the vertical columns. They are also called families. The reason they're called families is because every element in that group is alike. They have similar properties to each other. For example, the famous group, the noble gas group, all these elements are unreactive. That's their family characteristic, you can say. The other thing is periods, and periods are actually the horizontal rows. So here's a period, period 5, for example. Here's period 2, and the periods are numbered 1, 2, 3, 4, based on the shell. Remember, the electronic arrangement is represented by that number. So these are your horizontal rows. Now, on the left side of the periodic table, you will find the metals. So the portion of the periodic table on the left is the biggest portion, and these are your metals. Now, metals, by definition, are good conductors of both heat and electricity, and they're also malleable and ductile. Malleable means you can actually make them into sheets, which means, for the most part, think of them as soft. They don't have to be soft, but they're pliable. You can bend them, for example. But also ductile. You can string them into wire. And much of our wire is actually made of metal. That's on the left side. In fact, if you take a look, most of the elements on the periodic table are metals. Even things like magnesium and sodium and potassium, even though we're not used to them being metals, in their elemental form, they are metallic. The other side of the periodic table, the smaller percentage, are the nonmetals. Among them, very important elements like carbon, extremely important. That's what our bodies are made of. Oxygen, we require oxygen for breathing. Many other elements that are essentially required for life are here. Your famous noble gases are nonmetals. And by definition, nonmetals are poor conductors of heat and electricity, and usually they are brittle in their solid state. Brittle means break easily. So if you were to try to crush a metal, for example, it wouldn't crush into small pieces, but a nonmetal would. That's the idea. Like a crystal, think of it as a crystal that crushes into small pieces. Between these two, the metals and the nonmetals, you'll find the semi-metals, also called metalloids at times. These are also called metalloids. And they have characteristics in between metals and nonmetals. So they both conduct and they don't conduct. Because metals, remember, conduct, nonmetals do not. For this reason, they are called semiconductors. And semiconductors are extremely important. This element right here is the element silicon, which is used in computer chips. And now everybody carries a computer in their pocket. So these are extremely important. You'll see that the semi-metals actually make a little diagonal band in the middle of the p block, roughly. And they separate the metals on this side from the nonmetals on this side. And essentially, there's a stair-step line on your periodic table. And this stair-step line, any element touching the stair-step line technically is a semi-metal, with the exclusion of the element aluminum. Aluminum is actually a pure metal, or a real metal. It conducts electricity, it's malleable. So excluding aluminum, any other element touching the stair-step line can be considered to be a semi-metal. Let's discuss a little bit about the noble gas group. Now, we've discussed noble gases already. These are very important. This is group 18, essentially at the far end, at the end of the periodic table. And these are stable, unreactive, for the reason that they have filled outer shells. None of their shells need any more electrons. They are, you can say, happy. They're stable. And every element actually wants to become like a noble gas in terms of its electron configuration. So elements will react to achieve a noble gas configuration, as we'll see. This concept will be very important as we discuss element reactivities. Let's go through some more groups. Now we're actually talking about groups on the periodic table. Remember the vertical columns. The first group are called the alkali metals. This group includes the famous element sodium, and all of these elements are soft. In fact, you can cut them with a kitchen knife. Here you see a picture of one of these, sodium, being cut easily with a kitchen knife, very soft. They have low densities. One of them, lithium, can actually float on water, or it's less dense than water, we can say. None of these really, they react with water. That's why it's tough to examine them against water. But they have low densities. They're extremely reactive. If you just drop these in water, you'll get roughly an explosion. If you just let them sit out in the air, they'll react directly with the air, oxidizing. They form +1 charges. This is important, and we'll see why they form +1 charges eventually. But they are never found in nature as free. And why aren't they found free in nature? Because they are so reactive. Any small amount of it that's elemental will react completely. None of it survives, essentially. And here's what happens when you throw one of them in the water. You see a little picture. This is sodium being thrown into water. Notice it ignites. This is just being thrown into water. We'll show you this demonstration as we get to class eventually. Hopefully you'll have the pleasure of viewing one of these live before your eyes. So again, here is the periodic table, and the question of why are the group 1 metals, these, so reactive. And we said the reason every element reacts is because it wants to be like the noble gas. So every element actually wants to attain the same configuration as a noble gas. If you take a look at sodium, sodium element 11 actually follows neon element 10. Even though the first group is arranged on the left side, it's actually following the noble gases. So this group is actually right after the noble gases. It's very close to being like a noble gas. And you can say these elements are desperate to become like the noble gases. So that's why they are so reactive, because they're so close to becoming like a noble gas. So very reactive, the first group. Okay, here are a few pictures of the elements. And beginning with lithium, notice nice and light. Lithium floats. This is lithium. Then sodium, potassium, rubidium, and cesium. All of these, notice, are enclosed. They are enclosed containers because they will react with the air if kept outside. They have to be contained in closed containers so they do not react with the air. And here is a little caption that you can put on your t-shirt and wear. This is sodium reacting with water. And anytime sodium reacts with water, a lot of heat gets released. Sodium or potassium or any one of these metals, if they react with water, a lot of heat gets released. So here's a little caption for you. Water plus metal gives fire. The second group are called the alkaline earth metals, very similar to the name of the first group. But there's a reason why we call these alkaline. The word alkaline actually means basic in terms of chemical-wise. Because these, when you throw them into water, they form what's called a base. A base is a type of chemical. We'll discover bases in a future chapter. These are a little different than group 1. They're harder, they are denser, and higher melting, but also very reactive. In fact, here is the element calcium being thrown into water, and notice it reacts vigorously. Not as vigorously as group 1. Interestingly, all of these will produce gas. This is actually hydrogen gas being produced here. Both group 1 metals and group 2 metals, when thrown in water, will produce hydrogen gas, which is explosive, and that's why some of these are pretty explosive. So they form +2 ions, and we'll show you why they form +2 ions eventually. So here's some information about them. Here's a few pictures of them before we finish this first lesson. These are beryllium from the top. Then going down from beryllium, we have magnesium, very important metal. We have calcium, and then we have strontium and barium. So all of them look grayish, metallic. Looks like this barium has tarnished a little bit. It's been out in the air a little bit. Very reactive. In fact, reactivity of these increase as you go down a group. So as you go down a group, both for the alkaline earth metals and for the alkali metals, they become more reactive. So this should complete for us the first lesson. We'll talk about some other groups in lesson 2 of chapter 5.